Right. Good evening, everyone. So this evening we're just going to do a bit of an introduction to Skysight and how we're using it, as it's something that we're looking at buying as a club. So this evening I'll do a sort of a brief introduction as to what Skysight is and what we can do with it. I'll then go through what Skysight call the point features. So we'll look at the point forecast, a point SQT, a point windgram. We'll then look at how we can use Skysight to produce a route forecast, convergences and wave flying when we do the expeditions up to Aboyne and Portmoak, how we can actually plan a task using Skysight, and then finally something that's really useful and quite new is how we can actually use Skysight in flight. So as well as being able to use it on the ground as a tool to look where we want to go, we can actually use it in the flight while we're flying the glider. A lot of the stuff I'll cover this evening, we've probably done these my two presentations in the wrong order, is you've got a bit of an assumed knowledge. So if there's stuff you don't understand that's maybe more weather or meteorologically orientated, the question box is open, just chuck a question in and I'll answer that. But a lot of it is more how to use the software and how we can get the answers out if we already know a bit of a background knowledge about weather. So the first thing that we need to do when we open up Skysight, which I'll do in a second, is we need to make sure that we've got the glider icon selected, make sure we're in the right region. So Skysight forecasts for almost everywhere in the world, and they've got specific data sets for, be it Europe, they do one for Italy, don't quite know why, Australia, South Africa, and all these places. Unlike Ben's clock, we need to make sure the date and time at the top is correct. This is so that when we're playing through the day, we are looking at the right time and we're not looking at British summertime and we're actually still flying in GMT. And we can also toggle on and off the airspace. That just makes it a bit easier to know where we're looking when we are looking at the Europe map. So if I pull the screen up. So can everyone see my screen? Just so I pop a question down the bottom, that would be great. Perfect. Right. So this is the, well, it's technically Harry Entwistle's Skysight. This is what he won at the Intunis last year, but he's donated it to the club because he's currently away in Germany and isn't doing a lot of flying. So this is the home landing page that you get to when you come onto Skysight. So as we can see in this top left-hand corner up here, I've got the glider icon selected because it's the last forecast I was using. But if we wanted to do forecasts for paragliding or hand gliding, we just select up here to make sure we're looking at the right thing. Changing the regions, if we just come up to settings, this is all the different places on this right-hand side that Skysight forecast for. So you can see we've got Europe. We can see the last place that I've looked at is the UK. Then up the top, we've got date time. So I'm currently in European time. Not entirely sure why. Let's go to British summertime. That'll make it a lot more relevant. And this is how we'd toggle through the day. So this is looking at height of thermals that I've got selected here on the left-hand side at 4 o'clock today. You can move this along to about 2 o'clock even, 4 o'clock, and through the day. And if we wanted to understand how the day was looking overall, we can just hit this play button here and it will just run through the height of thermals step by step, and we can see how the day either gets better or the day might die off for any various reasons. And then finally, on this left-hand side, we can toggle airspace on and off, and you can see when it loads, come on, that we haven't got lots of place to work in the UK, but plenty of room out to the east where we are. So that's a very brief introduction of sort of what the software looks like and the little gotchas that we need to be aware of when we're using the software. So the first thing that's really key for Skysight is using their point forecasts. So there are 4 main point forecasts that they like to use. So what I like to use the point forecasts for is if I'm going local soaring. So it's something that I used to do a lot of, and it's something that I'm hoping to move away from, look at doing more cross country and using the other features on Skysight. But if you want to just do some local soaring, or you're an instructor and just wanting to look around Saltby for the day, if you're doing the daily briefing, the point forecasts are really good because you can get a really good understanding of what's going on in the local area. So if we just go back, so point forecast, we then work out where Saltby is. So fortunately, Skysight have mapped out all of the gliding centres with these little aircraft symbols. This is Saltby here. When it loads, so we can see that today it's been a fairly blue day in the morning, lots of sun, good surface heating. In theory, we'd add 3.5 knot thermals at 1/2. Soarable height is this red line here. So at 11:30, sort of first launch time, you're looking at thermals up to 2,000 feet. And by the afternoon, you're looking at thermals probably to 2.5, 3,000 feet. But as you can see, this pink line's the condensation layer. So the thermals didn't really extend close to cloud base today. We've then got other information you might be interested in, so surface temperatures and dew points. You can also look at wind speeds on the ground. So at 2 meters above ground, this is what we'd see on the ground, not a lot of wind speed. And then the wind at BL top. So BL stands for boundary layer. This is essentially the top of thermals or the inversion layer, whatever is highest on the day, essentially. And we can also see that pressure is falling steadily throughout the day. So that could be good if you just wanted to understand what was happening at Saltby locally, when the best times to launch are, what sort of heights you're going to be able to thermal to. And it's also good for instructors who just want to do a quick briefing if they don't want to use the other weather information sources that we might use, such as the Met Office. The other thing you can use it for, and this is being quite smart with the software, is let's say you were competition flying, you could look at the point forecast for all of the turn points of the day, and that could give you an idea of when's best to start. So if one turn point's looking good earlier on, and that's the first turn point, and another turn point's looking better later on, so that happens to be the second turn point, that's looking really good, and it'll give you a good indication of when to start the task. So the next sort of point feature that we can look at is point skew-T, or sounding. So again, we'll do it for Saltby. So I've clicked on point skew-T on the left-hand side. And I'm just going to click on this little plane here, which I know is Saltby. I'm not going to sort of tell you how to read this. That's a complete another lecture in itself. But as you can see, it's an interactive sounding or skew-T. So on the very right here, we've got the wind barbs. They're telling us the wind speed and direction at different heights. I've then got that graphically shown as a blue line. So you can see here that at 3,326 feet today at 2 o'clock, the wind would have been 249 degrees and 1.3 knots. I've then also got surface temperatures and dew points. So surface temperature obviously in the red and dew point in the green. And then pressure on the side. What's quite nice is if I move my mouse in, as well as giving me the altitude in hectopascals, it's giving me the altitude in feet. I won't go into that too much more, but that's there. If you know how to read one, you can get a lot of data out of these. The final point forecast is what they call the point windogram. I'm told this is something that not a lot of people use, but you can use it very effectively if you know how to read it. So again, I'll click on point windogram here on the left-hand side, and I'll click on Saltby. So the first thing it shows is lapse rate. Now, lapse rate essentially is a measure of how stable the atmosphere is. So here we've got our lapse rate written on the right-hand side, and if we're down at -4, that means it's very unstable and we're going to get good thermals. So what we can see if we were reading today is it's fairly stable to start off with, sort of between 8 and 9 in the morning, becoming more unstable as we get to 10. So this would probably be start of thermals at 10 this morning. Building throughout the day, and we can see that we've probably got unstable and thermals up to, this reckons, probably 3,500 feet, and then starting to die away again as the day dies, sort of becoming 7 o'clock, 8 o'clock. We can change this again, so we could look at temperature, cloud. So obviously what we can see here is because the screen's all pink, there's 0% cloud. Something to be careful if you do end up using this feature is it only shows really predominant thick cloud. It won't show small patches of Q that you might want to use for soaring. So I wouldn't use this if you wanted to understand anything to do with soaring clouds, but it would show you if there was any sort of significant cloud that could overdevelop and close soaring off early. Relative humidity, so what we can see is it's fairly moist down low, drying out, and this is effectively our cloud layer, and then going fairly moist again as we go above. And then wind speed, if you wanted to sort of understand what the wind was doing during the day. So as we can see, there's no real sharp gradients in the color here, so the wind's fairly stable throughout the day. I'll just pause here for a second. If anyone's got any questions about what I've covered before I jump on, just chuck it down in the chat and I'll answer them. How accurate do I think these charts are? I'd say for the UK, they're reasonably accurate. So a lot of the charts from the Met Office say have a grid spacing of 10 kilometers. But these have got a grid spacing of 5 kilometers, so they're a lot more accurate. So if you imagine you've chunked the UK up into sort of 5 kilometer squares rather than 10 kilometer squares, you've got a lot more data. I found it reasonably reliable last season when I was using it. Once I'd been told how to read it right, I wasn't reading it very correctly. But yeah, I've been pretty happy with the forecasts that I've got so far from this, John. Right, so what I'll move on to now is how we can use Skysight to do route forecasting. So the first thing we need to do is we need to select the glider we're going to be flying, because that's always taken into account when we build automatic route forecasts within Skysight. So you can find out the handicap for your glider on the link there, but for the Aster CS77, that has a handicap of 89. So we go into settings, we go accounts, And what I can do here is I can put in my pilot/glider factor. So I know for the Asteer, that's 89. But then I also know that I'm not very good at flying the Asteer, so I'm going to give myself a personal handicap of 2, and I reckon I'm about 87. So as it says here, higher is faster. The default is 100, which is around a Ventus 2 flying at 45 kilograms per square meter. That's to do with the wing loading due to the water they're carrying. So if I update the profile, that's now saved. So I'm now flying the Asteer with a jack handicap of 2 points. So now go back into Skysight. Takes a while to load. There's lots of calculations being done. But as you can see, even by leaving it, it still saved my settings of changing to BST, etc. So what I want to do is, so with suggested tasks, I come down to, so on this left-hand side, I've got route forecast. So I click on route forecast. What I need to do is select a starting point. So if I zoom in a bit, I'll select Saltby. And so I can continue drawing my own by just clicking on various points around the map, or I can get Skysight to suggest its own task for me. So I want to do a medium length triangle, and I want to start at 12 and be home by 4 o'clock. And change everything again and generate. And what Skysight will do is it will take in all sorts of things into account, and it will produce the task, the best task it thinks that I can fly with a handicap of 87. So it has suggested for me a 115-kilometer triangle. So starting at Saltby, going down to sort of the Corby area, out towards sort of Peterborough and Spalding Gliding Club, or Crowland up here, and then back in. So it's then giving us lots of data that we can use. So this chart in sort of the middle here gives us the train, so the height of train down the bottom, so we can see that, actually I had it the wrong way around, our first leg out towards Peterborough, we can see that we're going down towards sea level. And I'm going to start to come back up, like so. Then got soarable heights throughout the day. So this is the red line here. So just below 3,000 feet all day, no real big changes. So it's a fairly standard, simple day to read, no big changes. Tops of thermals. So this is essentially cloud base. So it reckons that thermals are going to start to peter off before you even get to cloud base. There'll be no cloud climbs. So it reckons cloud base is just short of 4,000 feet throughout the entire day. And all of these are QNH, as you can see down here. We're at effectively sea level, but there's no real big dips because it's all given in QNH. And then this is the top of clouds, your condensation layers, essentially. So where the clouds will stop forming. On the right-hand side, we've got the optimum start times for the task. So it reckons that if I start at 12:30, it's going to take me 3 hours and 50 minutes and I'm going to do it in 31 kph. It reckons if I start at 2 o'clock, I can do it at 40 kph, and it's going to take me 2 hours and 53. But if I start any later, it says it reckons I'm going to land out. So what I'm currently showing you is the point-to-point forecast. So it's literally if I was to fly from one point to another. What Skysight can do is if I click on this button here that says optimized, and wait for it to do all the calculations again. What this will do is, instead of telling me to go point to point and telling me what the weather's like on that, it'll tell me the quickest way to get around the task and how much I need to deviate by. In theory, unless the optimum task is to go point to point, which it shouldn't be. So anyway, what you'd normally see if you clicked on the optimize button is you'd see a black line that probably came out this way and then came back in, then maybe went out into the middle and back in, and then out this way. And all that's doing is it's telling you the best route to take. Now, as I said earlier, you're able to actually put Skysight into your UDIs these days, so you'd be able to follow that line to know where the best weather is. What's also nice is once you've done this task and it's given you the best task you think you can fly for the day, you can hit this download button, and you can either download, as you can see here, the XC tasks or the cup file, so you can load it into your UDI or just into your phone, and obviously that will then help you with declaring the task if you're going away to do badge flights. So what I'll do is, today's a bit of a rubbish day, so I'll run you through it again, but I'll do it for Monday. So as if by magic, yes, there was a really good day to go flying. So again, we'll click here on route forecast, starting at Saltby, and I'd like to do a long triangle, and we'll see what it predicts me if I was to fly yesterday. So it reckons in the Astir, if I'd have flown yesterday, I could have done a 605-kilometer triangle. That would have been nice. But again, it's still showing me all the same data that we were shown on the last task. And if you look here, it's got all of the speeds we can do. So it reckons if I'd have flown on Monday, I've had to have started by 10. I'm not entirely sure what's gone on here. Must have been to do with something with the calculations. If I'd have started at 10, it would have taken me 7 hours, and I could have done it at 86 kph, and you'd have got a nice big triangle in. Does anyone have, what I'll do is if I open it up, I'm pretty happy. Any sort of questions, want me to look at anything different here before we look at the next thing?
What's the big dip, Jack?
In the red line.
In the soarable conditions, is that
about 14 foot?
Is it over-convect or something like that when you were looking at that one?
I think we crossed. There must have been. I think we crossed the end of this river.
Oh, right. The Cheshire Gap. Yeah, yeah.
But yeah, that was slightly strange.
Well, you probably have to get high and glide across it.
Yeah. Where are we, Derby? With this
then it looked like an overdevelopment. So was that what the grey patch was further on in the afternoon?
Yeah. So when it's got the grey, it's like it was really thick cloud, is what it's predicting there.
Yeah.
So yeah. So here, this sort of thick patch is it essentially means it's really thick cloud. So yeah, there is a big risk of sort of overdevelopment here.
Yeah, and at 3 o'clock, at 3 o'clock, you can actually look and see where you would be at 3 o'clock.
Yeah.
On the task. See, I think. Oh look, yeah, I think you're out by the wash there. If that's the point. Yeah.
Oh, yeah. This is a slightly different task. But yeah.
Right. Okay. Yeah. It's really clever, though, isn't it?
So that's obviously. That's predicting, like that's giving you the best task it can do. You can, if you know what task you want to fly. Let's say you just want to do Club 100 or a task you can just same way, just click on the 3 points. Let's start at Saltby, go to Crowlands, Melton, and back again. And it will do the same predictions, but for a task that we've drawn rather than one it suggested. And this is what I was saying about the optimized task. These are the black lines that it reckons I should fly to be the fastest. So this one's not too bad. It's fairly sort of point to point. But if you're doing a bigger task, it might have a bigger deviation to follow better air. Right, so what I'll do now is I'll move on to convergences and wave flying. So convergences is something you might experience if you had a big sea breeze with a backing wind. Fortunately, doing a bit of homework, these are really prevalent in South Africa. So if we wait for South Africa to load, what you'll be able to do is see them reasonably clearly and show where you'd want to fly, essentially to allow you to fly in straight lines and still be going up. So if we scroll down on this left-hand side here, we've got various different things we can look at. And if we find the one called convergence, what we can see here in Namibia is this sort of front is what it almost looks like. Not very pronounced yesterday. My computer is so slow. But what we can see here is sort of the sea breeze coming in. So we've got sort of a bit of down here, but then we've got this up. And if we were fortunate enough to want to be flying along one of these, we could just sit in it, fairly similar to the wave, and still be going up. So that's how sort of convergences work. But if you want to sort of understand it a little bit more, you can use this function here on the left-hand side called the wave cross section. So what we do with that, if we click on there, and we can click on one point one side of it, and another point on the other side. What we can do is we can understand what's going on. So any of this sort of dark, the purple, red stuff, that's all positive going up, and the blue stuff is all negative. So you can see that as we move across that section that we've just drawn here on the left-hand side, we've got a bit of zero, bit of sink, bit of up, and if we were flying out, some sink, and then some strong up here, and then again a bit more sinking out. And that's useful to know if you do find these on your task, how you could use them to your advantage so you don't have to turn as much and you get a faster task speed overall. We can do a similar thing if we want to do wave flying. So let's go back to Europe and let's go look at somewhere in Scotland. No guesses as to where we're going. So if we want to do wave flying, what we want to have a look at really is any of these wave cross sections. So if we think that we're going to be flying 1 kilometer high, we can click on this one and we can see where the wave's going to be for any given day at a given time. So not a lot of wave yesterday at 4 o'clock, probably likely due to the low wind speeds we've been having. If we go slightly higher, we might find something that's a little bit more pronounced. or maybe not. But then if we look through the days, we might be able to find something. So that's a bit better. So what we can see here is we can see the down here sort of in the blue, and then we've got the up here. So we've probably got primary here. We've not really got anything going on behind, something very small. But that shows you where you'd want to be flying in the up, essentially. There's a button down here called 3D Wave. For those of you who haven't flown in Wave, this might help you visualize it. So what the 3D Wave is, for the engineers out there, it's an isosurface of all the areas giving you anywhere that's above 1 knot. So what you can see is these masses here is essentially where we want to be flying to stay in the wave. Now, the cleverest thing you can do with Skysight really for Wave, apart from knowing where it is if you wanted to plan a wave task, we could use that wave cross-section tool to help us. So we're unlikely to do something like this, but it is useful. So if we start drawing points across the wave bar where we're likely to be flying, you can see that the line I've drawn so far at sort of 2,000 feet is pretty good. We've got 4 knots, then it drops again down here to 2 knots, picks up again to 4 knots, and then we sort of fall out the end of the wave bar before we've maybe got to where we'd like to go. So what we can do is we can drag and put as many points as we like on this line, and hopefully, if we do this well, we can try and get this sort of 3-4 knots up to happen the entire way across our task, so we can be nice and fast.
Jack, is that air mass or is that lift? Do you know, is that your climb rate or is it just the air rising rate?
So this is climb rates.
Climb rate, okay.
Based on your Aster?
Yes,
still based on my Aster.
With a Jack handicap.
With a Jack handicap.
Handicap doesn't count as one.
But so what you could do is you could keep on moving this around until this was sort of all red in a nice line, and you knew that if you were flying at 2,000, 3,000 feet, you could just be flying as fast as possible. This reckons that cross-country speed down the bottom. So for an 18-meter glider, it's showing me both, I'd be able to do it. I'd be able to have a task speed along this sort of line of 174 kph. This is more useful. This is more useful if you just want to have really fast tasks, or you're trying to just plan long tasks. Because obviously, all I've done here is fly along a wave bar. I haven't really done anything clever about this, but it's something to note if you want to set wave tasks on expedition. So sort of second from last, what I do is we'll look at planning a task a bit more sort of holistically, rather than just getting Skysight to draw something for us. So we're sat in the clubhouse at 8 in the morning because we're really keen. We've rigged our glider and we've looked a few days before. We know it's going to be good, but we now need to decide on the task we're going to fly. So if I go back to Monday, because it's a much better day, the first thing that I suggest people use is the potential flight distance. So if I click on that, and we're keen, so we're going to take a launch about 10:30. So what this is showing us is the potential flight distance for the Aster with a Jack handicap. So it reckons, taking off from Saltby, which is here, it reckons the biggest task I could do is around 610 kilometers. As we saw, it predicted me a 605 kilometer triangle. But with that said, it reckons 600 kilometers. I reckon that means that I could probably do a 300k and not land out. Next thing I want to do is use this one at the bottom of the thermals, which is significant weather. So what this will tell me is, are there going to be any thunderstorms? Is there severe wind? Is there anything that's going to either cut the task short or be a big risk on final glide? So, okay, what this is showing me is there's going to be, if we're launching from the Buckminster area, it's going to be quite windy with sun and clouds. And then if I was to task sort of north, you can see that maybe some of this cloud but no, so no, so we're fairly happy. And then just start to think about final glide, so around sort of always good to understand what the air mass is doing. So see how much overglide we need to be. So 4.5 knots. So we might think about putting water in then in the morning if the average climb rate over the day is somewhere between 3.5 and 4.5 knots. The next thing that's probably worth checking is Q cloud base. So how high are the climbs? So we go back to when we take off at sort of 10 o'clock. So at 10 o'clock, we've essentially got a 3,000-foot cloud base above Saltby. That's perfect. Middle of the day, halfway through around the task, we've got a 4,300-foot cloud base. What we've got here, where it goes really grey and scrappy, this just means that there's no cloud. It's nice and blue here. But what it's trying to predict is the inversion height. So as you can see with where my mouse is, you've got a height. So here it's telling me there's no cloud and the inversion is at 4,250 feet. So using those sort of the Q cloud base, and you might want to look at height of thermals because obviously thermals don't always go to cloud base. This might give us a sort of an idea of the direction we want to task, where the thermal is going to be best. So on this task, we probably want to work somewhere northwest would probably be good. And then to check that I'm not about to do something silly, let's just switch the airspace on. So the weather looks good in that direction. Can we fly in that direction? So yes, we've probably got to be careful of East Midlands and what's going on as we get up here. But yeah, we can definitely task in that direction. And then the final thing you sort of want to do is then go back to the route forecast that I was using earlier. Click on Saltby as your starting place. And we want to do medium. Let's do an out and return, something slightly different. And it reckons I should be doing 432-kilometre out and return, and it reckons I should have started yesterday around 11, and it would have taken me 4 hours and 10 minutes. So a clever way to check that you know you're going in the right direction is to use XC speed here on the left hand side. So what that'll do is, again, this is the Asteer with the Jack handicap. As you can see, the places that it thinks in the UK that are going to give you the fastest task times, and you can see definitely that sort of this northeast area is going to give us the fastest task speed, so it's the best place to task for the day. What can be useful and something I haven't done, something I should do, is when planning a task, is we can upload all of the BGA waypoints if we have the relevant cup file, and then we can pick points, which obviously makes this a lot easier to do rather than picking random places. And then sort of the last bit before we sort of do a bit of a discussion about this is how can we use Skysight in flight? Well, if we have UDI, I'm not sure if you can do this on XC-Saw, but you can definitely do this on a UDI or an LX9000 if you're that way inclined. You can essentially drop any of those charts that I've shown you this evening as a background onto your UDI. So let's say we were flying out of a Boeing on expedition, we'd maybe put one of those wave ones on. And what you can do is you can literally fly to where it predicts the wave is, and assuming it's going a good prediction for that day, you should be going up or down depending on how good your flying is. So to do this, you just fire up CU. So if I get back to screen sharing. So if you just fire up CU, obviously at this point you'd need your UDI plugged in, or you'd need to be using UDI CU Cloud, so you could do a download into your glider if you're using something that's fixed. You then need to pay for CU, something you can't do on the free version. Either Top Meteo or Skysight. Top Meteo is very similar to Skysight. You click on Skysight, put in your Skysight email, download on demand, select Europe. You need to put your pilot factor in, so mine was 87. Hit the reload button, and that will download all of the charts for today into CU. And then when you go into CU further, you can select which ones you want to pull across to your UDI for the day. And then you can just flick through them on your UDI as if you were changing maps as you would do in flight normally. So I appreciate that was sort of reasonably a quick overview of Skysight and what you can do with it, but I hope you found it useful. If anyone has any questions, wants me to go over anything again, just let me know. I think everyone can just unlock their mics and chat, or put a question in the chat box down